Hey, it's Mr. Allred here, and we're going to solve a system of equations. This is a practice problem. The first equation we have is negative 3x minus 3y equals 3. And the second equation is y equals negative 5x minus 17. So you should recall that we had two main methods of solving equations, a system of equations, and that was substitution and elimination. And I didn't tell you which method to use here, so you could use either you like, and you should get the same answer. And depending on the amount of time I have in this video, I'm going to attempt to solve it both ways. But we want to make a determination which way might be best. So first of all, think about the two things. With elimination, our variables need to be lined up. So if we look at where the equals are, we don't have all our y's on the same side. Well, we do, but we don't have all our x's on the same side. So in the first one, x and y is on the left, and the second one, only y is on the left. So we'd have to move some stuff around to do elimination. But if we wanted to try substitution, we always start by getting a variable by itself, and y is already by itself. Y in the second equation is negative 5x minus 17. Which means substitution would be a good method because we can take that and plug it into the first equation. So the method I'm going to start with is the easier of the two, which will be substitution. And in the substitution method, the first step was to get something by itself. And we'll say get y by itself, which it already is. Okay. It's y equals negative 5x minus 17. So step 2 would be plug the negative 5x minus 17 into y in the first equation, negative 3x minus 3y equals 3. So when we do that, we'll have negative 3x minus 3 times the quantity of negative 5x minus 17, and that's all equal to 3. So again here I'm replacing the y with the negative 5x minus 17. So the next step is to solve this. I'm going to come up here and say solve for x, since that's the variable that's in there. There's only one variable now. So I'm going to work on cleaning that up. So I'm going to use the distributive property. Negative 3x stays, but I'm going to distribute the minus 3 through. So it'll be plus 15x plus, and I believe that's 51, equals 3. So I'm going to keep cleaning up. I can combine some like terms here in the solving process. So that's 12x plus 51 equals 3. And then I need to get all my x's on one side, which is already on the left. So let's get the non-x's on the right. So we'll subtract 51 from both sides. So there is 12x equals negative 48. And the last step of the solving the linear equation is divide both sides by 12, which gives me x equals negative 4. Yes, that's the answer I had earlier. So once I have x, the next goal is to solve for y, because we need both the x and the y. And in this case, we had in the second equation y already by itself. So y equals negative 5x, but let's replace x with negative 4, minus 17. So we're replacing here, let's pick a new color. I don't know what the purple looks like, but we're replacing the x of negative 4 in for the x in the second equation. And there we will just evaluate. So y will be 20 minus 17. Y will be 3. So the solution to the system of equations should be x is -4 and y is +3. And we solved that by substitution, and we followed those steps. Okay. So now, if you want to see it with elimination, that's what we're going to do. We're going to try it the second way, and we're going to attempt elimination. Okay. So we've got the same equation, and we're going to try elimination. So remember, the first step of elimination is to line up the variables. So I'm going to take the first equation, which is -3x minus 3y equals 3, and leave it alone. Now the second equation, which was y equals -5x minus 17, I'm going to take that minus 5x and move it to the other side. So it'll be a positive 5x when I move it to the left. And the equation, when everything is in the right place, will be 5x minus y equals -17. So now I have x's in a row, I have y's in a row, and I have my equals in a row. So everything is lined up. But I don't have like variables with the same coefficient. -3 and 5 on the x won't cancel out. -3 and -1 won't cancel out for the y. So what I'm going to do is I'm going to, in this case, multiply the 5x minus 3y equals -17 by, in this case, a -3. Okay, and the reason I'm going to do a -3 is I want to change what's in front of the y in that equation to a +3, so they'll cancel out. So let's kind of set that up. Okay, we're going to take the first equation, which is -3x minus 3y equals 3, and we're going to multiply the second one by 3. Excuse me, -3. So when I do that, -3 times 5x will be -15x. -3 times -y will be +3y. And -3 times -17 will be a +51. So when I add those together, okay, adding those together, boom, boom, boom. I'm looking for, my blue pen. I'll have -18x equals, hold on, 54. Yes, 54. So bringing that up, I'm going to take -18x equals 54, and I'm going to solve this one for x. So I'll divide both sides by -18. And if everything is going correctly, which seems a little out of place here, 51, 34, 51. Let's pick up my calculator. Having a little doubt here. 54 divided by 18 is 3. Trying to figure out why I have 3 for x. I'm going to pause while I think here for a moment. Okay, I figured out my mistake. And what happened here, when I was trying to get the x and the y on the same side, I added 5x's to both sides, so that brought this over. But the y was positive, and it should still be positive. So I'm going to fix that. And in that case, I'm only going to need to multiply by a +3. So we're going to go back and we're going to fix that and multiply by a +3. Because multiply by a +3 will cause these two to add together and cancel out. So let me erase this second line. Sometimes when you make a mistake, you need a moment to kind of go through everything and find it. So let's see here. When I multiply 5x plus y equals negative 17 by positive 3, I'm going to get 15x plus 3y equals negative 51. So the 3 y's are going to still cancel out. But when I combine those, I'll have 12x equals negative 48. And that should look familiar for when we did it with substitution. So I need to solve that for x. So I'm going to divide both sides by 12. I apologize for the error there. And then I'm going to have x equals negative 4, which is what we had when we worked it the first time. And then the last step we're going to do is we're going to plug in x equals negative 4 to solve for y. And hopefully we get 3 like we did in the previous video. So we'll plug it into the second equation since y is already by itself. Y equals negative 5x times negative 4 minus 17. So making sure you see that I took the negative 4 and plugged it in for x. This is the exact same way we ended the last problem, or last way we worked it. So cleaning up, we get y equals 20 minus 17, or y equals 3. All right. So we got the same answer using elimination and substitution. The methods are a little bit different, but that's the idea. We can use either method to get what we want. Sometimes one way is a little bit easier than the other.